Hello good people, and welcome back. In this video what we're going to do is wrap up the discussion of unit 4, and in this unit of course we are discussing the mechanics of option markets. And the last video ended with the discussion on the terminology. We talked about moneyness, we talked about at the money option, in the money option, and out of the money option. We said that when we're working with the money as an option, we are completely ignoring the premium that's paid for the option. And so when we say an option is at the money, all that simply means is that the strike price is equal to the stock price at that point in time. When we say that the option is in the money for a call option, that's going to mean that the stock price is above the strike price. When we say that and for a put option, it's going to mean that the stock price is below the strike price. And when we say that a call option is out of the money, that simply means that the stock price is below the strike price. And for a put option, it would mean that the stock price is above the strike price. And we showed how with the various graph for a long call and a long put option. We're going to continue with the terminology here. We're going to talk about the option classes. Well, an option class is nothing else but the type of option, right? So, and we generally have two. There's calls versus puts, right? So the call option is call options are essentially one class of options, whereas put options would constitute another class of options. An option series is nothing else but a set of options within a class that have the same maturity or same expiration as well as the same strike price. So the series is essentially a contract. That's what an option series is. The proper definition of an option series is a set of options. So a set of options, right, in the same class. And we said that the class could be either a call or a put, right? So it's a set of calls or a put that have the same expiration and the same strike. And so if you have an option contract, a call option contract that has, say, 100 options, that would be a series, because all of the options within this contract have the same expiration and the same strike. And so an option series is essentially an option contract. Now, the intrinsic value of an option is nothing else but the definition of what the payoff of the option it would be if the option is exercised right away. So for a call, that intrinsic would be the payoff, and so the intrinsic value, if you recall, for the call was the maximum of the stock price minus the strike price and N0. That was be the intrinsic value of a call option. Now, the intrinsic value is the quote true value, right? Do you remember your corporate finance class when you talked about the intrinsic value of a stock versus the market value? And so with respect to options, we're going to have what we refer to as the total value of the option. So that total value is going to be equal to the intrinsic value plus something that we're going to refer to as the time value. And so the time value here is a component, captures the difference between the actual value, the market value of the option, and its true value, its intrinsic value. Now we're going to talk some more about time value of the option a little later. Now, there are a variety of options that are traded out there. Initially, we talked about the classes. So we have two classes. There's going to be calls and put, but within each class, there are different type of options. We can look at flex options that are traded on the CBOE, and the flex options are essentially those options contract that are not standardized, that are customizable. And although the CBOE is an exchange where contracts are typically standardized, that's not the traditional option contracts, the CBOE also offers flex options, which are flexible options, in an attempt to capture market share from the over-the-counter market. So remember, over-the-counter versus exchange, the OTC market is highly customizable, whereas the exchange is not so customizable. The exchange is standardized. So the option market in the exchange is very standardized, but in addition to that, the CBOE also offers customizable options, and those customizable options are referred to as flex options. Now, those flex options have a minimum number of contract or options that can be traded per contract, right? So, for example, a flex option would have a minimum of 100 options per contract. Binary options, on the other hand, here, I'm going to use my highlighter, and binary options are essentially options that provide a fixed payoff if the strike price is reached. So for a call, you recall for a call we said the payoff would be the maximum of the stock price minus the strike price, or 0. And the payoff on the call, the traditional call that is, depends on what the value of the stock price is, right? The strike price is fixed, so the value of the stock price might change. So if the stock price, say, is 100 and the strike price is 70, the payoff of the option contract would be the 30. That's that difference there. Now, if the value of the underlying is 120 and the strike price is 70, that payoff would be 50. So the payoff is going to change depending on the value of the underlying. With binary option, that's not the case. With binary option, the payoff is flat. So for a binary option, we're going to have a flat payoff. Let's call that Z. That flat payoff is not going to change. So as soon as the strike price, the stock price is equal to the strike price, the binary has a payoff that's positive and is equal to that value. It doesn't change. That's binary option. We also have CBORs, and CBORs are credit event binary options. They function like binary option, right? So we have a flat payoff. But what triggers the payoff? With binary option, the trigger for the payoff is the fact that the stock price is equal to the strike price. With the CBORs, what triggers the payoff is an event, and that's what it is here. It's an event. And generally, that event is a bankruptcy, for example, of the underlying firm. So the firm that we are referring to, or the company that is the object of the contract, or often referred to as the reference entity. So the reference entity would perhaps go bankrupt, and in the event that the reference entity, which is the company underlying the contract, in the event that that company goes bankrupt, the CBORs is going to have a fix, just like a binary, a fixed payoff. So the trigger in this case is the bankruptcy of the reference company or the reference entity, and the payoff is going to be a fixed payoff because it is a binary option after all. We also have the doom options, and the doom options here are very similar to the CBORs. So the doom options are deep out of the money option. You remember, out of the money put option. That's what they are. Deep out of the money. And we're going to make sure we highlight this, put options. And they're deep out of the money put options because the strike price is so low, right? They have a low strike price, which means that for that strike price to be reached, or that strike price to be hit, the value of the underlying has to go so low. And for the value of an underlying going to go so low, it simply means that the firm that we are looking at, or the stock that we are looking at, might be in distress. And so that might create an event that's very similar to the CBOS, which is a bankruptcy. Those are doom options. Well, we also have weekly options that are not listed here. Those are weeklies. And the weekly options, or the weeklies options, are short-term options. And those short-term options are typically created on Thursdays and expire on the Friday of the following week. And those would be weekly. So these are traditional options. They are unique because they only last about 8 days. They're created on the Thursdays and they expire on the Friday of the next week. So that the lifespan of these options contract are typically about a week or 8 days in this case. Next, suppose that you own options with a strike price of K to buy or sell N shares of stocks. So those are options to buy, call, or to sell, put options, N shares of stocks. Should cash dividend be paid, no adjustment is going to be required to the strike price. So no adjustment are made on the options terms for cash dividend. So if the N shares, or the firm that you're trying to purchase, from which you're trying to purchase the shares, if the underlying pays cash dividend, and we need to emphasize this, cash dividend, we don't need to make any adjustment to the option terms. So the strike price is not going to change. The number of shares that you will be purchasing is not going to change. Nothing changes with respect to the option. The reason nothing changes with respect to the options is because those cash dividends are typically small. They are very small, and also they are paid quarterly. So the cash dividend is not going to have a material impact on the option value and the number of shares that you're looking at. Now, when there is a stock split, where within this for the stock split you are given N shares for every M shares that you own, that is the stock split, we have to make an adjustment. And the way we make an adjustment is simply by adjusting the strike price to reflect the split. And the adjustment to the strike price is going to be to the tune of this expression that we have here. So if we have an N for M stock split, the strike price is going to reduce to this value. That is equal to M, which is the number of shares that you're giving up, multiplied by the current strike price, divided by the number of shares that you're receiving in exchange for what you're giving up, and that will be N here. So if we are having, for example, a 2-for-1 split, for every shares that you give up, right, you're receiving 2 shares. The strike price is going to be adjusted by 2. That's not 2. 2 here. Need to correct this. 2 here, and then N is going to be equal to 1. M is going to be equal to 1, so it's going to be 1 and strike price. In this case, you're essentially going to divide the strike price by 2. And we'll see an example here in a second. Now, the number of shares, in a very similar manner, is also going to be adjusted, right? So if we have a 2-for-1, and you initially wanted to purchase 100 shares, your 100 shares are going to be replaced by 2 shares per unit, so you're going to have 200 shares. And the way you get that is simply by multiplying N, that is the number of shares you're receiving, by M, capital N, which is what you were after initially, and divide that by the number of shares you're giving up per split. So in this example, where we're working with a 2-for-1, if you say you wanted to buy 100 shares per this option contract, if N was 100, you would have 2 multiplied by N, which is 100, divided by M, which is 1, and M will be 1. So the number of shares you will be purchasing based on the contract would now be 200 shares instead of the 100 shares that you had earlier. And you'll be purchasing the 200 shares at the strike price that's equal to half the initial strike price. And that is the adjustment that you'll be making there. Now, if the stock is receiving dividends, those dividends are also handled in a different manner, or in a manner that's very similar to this, right? So here we're working with cash dividend, but then in this case we're working with stock dividend. So the stock dividend is very similar to a split, right? The stock dividend means that instead of receiving cash as a compensation for holding the stock over the period of time, that's what dividends essentially are, you're receiving additional shares of stocks. And we'll look at an example here in a second. Alright, so let's look at this example where we have a call option, right, to buy 100 shares of a stock for $20 per share. What does that mean? For us, it simply means that we are looking to buy capital N 100 shares. The current strike price K is equal to 20. And it turns out that we need to make adjustment for stock split. And what stock split says is that we are getting a 2-for-1. Now, by our definition, we would have N for M. So N would be equal to 2 and M would be equal to 1. And so the first adjustment that we need to make is with respect to the number of stocks. So that's going to be the number of stocks underlying this contract is not going to be 100 anymore. So how many stocks are we going to have? The number of stocks is going to be equal to N multiplied by capital N divided by M. Now, what do we have in this case? Well, N here is 2, so it's going to be 2 multiplied by capital N, which is 100 times 100, and we're going to divide that by M, which is 1, divided by 1, so the number of stocks is, in this case, going to be equal to 200 shares. So for every stock that you give up, every one of these 100 stocks, you get 2. Essentially, we're doubling the number of underlying that we had. Now, what is the adjustment that we make to the strike price? Well, the adjustment that we make to the strike price is going to be equal to M multiplied by the strike price divided by N. Remember what N is? N is equal to 2, so that's going to be, and M is equal to 1. So 1 multiplied by strike price in this case is 20 divided by N, which is 2. So we have 10. So it used to be that we would be paying $20 per share for 100 shares. So essentially, we'll be spending 20 times 100, that's 2,000 for that contract. Now, with the split, a 2-for-1, what do we have? We are paying $10 per share for 200 shares. We're still having a $2,000 outflow. So the outcome is exactly the same from what we had initially. We just adjusted the strike price to reflect the new number of shares that we have, the 200 shares that we have. How do we make the adjustment with the 5% stock dividend? With the 5% stock dividend, what that means is the number of shares is going to be increasing by 5%. So that's fairly straightforward. The adjustment that you need to make for the number of shares is simply going to be equal to the capital N multiplied by 1 plus the 5%. And so that is going to be 100 multiplied by 1.05. So that gives us 105 stocks. That's what we have. So we can now find the adjustment that we make on the strike price with respect to this 5% dividend. Well, to find that, what we're going to say is, in effect, the 5% the 5% stock dividend is a stock split. And the reason we know it's a stock split is because in this case, what we're doing is we are giving up 100 shares and we are receiving 105 shares in exchange. So we can implicitly say that 100 is what we are giving up, that is M, and N is the number of shares that we are receiving, that is N. And so our strike price, our adjusted strike price, is going to be equal to the same thing that we have here, M, which is 100, right, divided by N, which is 105, multiplied by the strike price that we had earlier, which is 20. So I'm going to pull my financial calculator and make sure I do that correctly. So it's going to be 100 multiplied by 20 equal, divide that by 105 equal. So my strike price in this case is going to be equal to 19.05. And that would be the adjustment that I would need to make on my strike price. Next, what we're going to do is talk about market makers. And market makers are these large financial institutions. It's a select group of financial institutions that typically take the other side of our transactions in financial market. And in effect, by taking the other side of most transactions, what they do is they provide liquidity to the financial markets. And they are also utilized in the market for options. And so most exchanges are going to be using those market makers in order to facilitate the trading of options, making sure that those option contracts are indeed liquid. The market maker is going to be quoting the bid and the ask prices. Those are bid and offer prices when they are requested to do so. So remember that the bid price is the amount of money that the market maker is willing to pay for an asset, and the ask price or the offer price is the amount of money that the market maker is willing to accept for the sale of an asset. And so the ask price or the offer price is typically greater than the bid price. Now, by how much can the ask price be greater than the bid price? Usually there's a limit on how wide that range can be. The exchange regulates that to an extent. The market makers also do not know, because they quote the bid and ask prices, they do not know whether the individual that's requesting the quote wants to buy or sell. That is to make sure that the market maker is not taking advantage, or the market makers are not taking advantage of those market participants. Now, this happens on the exchange, right? And we remember that one of the essential features of the exchange is the ability of the exchange to help reduce credit risk. And the way exchanges do that is by requiring margins to be posted. And so margins are posted in the option markets when the option is written or sold. So when options are written or sold, the margins are required to be posted by the writer of the option. And that's primarily because the downside or the potential losses that are associated with writing an option are generally unlimited. And that's even so if you're writing a naked option. A naked option is an option contract that's written when the writer of the option contract does not own the underlying. So you're writing a call option contract that gives the right to somebody to buy from you an asset at some point in the future at a specified price. However, you currently do not own the asset, and therefore if the option is exercised, you as the writer of the option contract will have to go out in the market and purchase the asset for delivery. And so that would be a scenario where margin would make sense, because the downside is can be huge. Now, how are margins computed? Well, the margins are computed in two ways. And the ultimate size of the margin that is required is the greater of the two ways, the two approaches. And the margin requirement is also a function of whether the option contract is a call option or a put option. So we have two methods. We're going to use the two methods, and then we're going to take the maximum of the two methods. Now, the first method, which is to take the total of 100% of the proceeds from the sale of the option plus 20% of the underlying share price minus any amount or the amount by which the option is out of the money. That is the first method. This first method that we have here works for both the call and the put option. The second method of computing the margin, which is what we have here, depends on whether you are working with a call option or whether you're working with a put option. If you're working with a call option, that second method says that you can use a total of 100% of the proceeds from the sale of the option plus 10% of the underlying share price if you're working with a call. However, if you're working with a put option, what you would have to do is to use 100% of the proceeds of the sales plus 10% of the exercise price if you're working with a put option. And that is the difference between the two. And if you're working with some other forms of options, because these are plain vanilla options, if you're working with some other sort type of options, or say exotic options, for example, the margin requirement gets a lot more complicated. But if it's a basic option contract, call or a put option contract, the margin that requirement is a function of these two methods. And what we do is we take the greater amount of the two methods, that is the highest amount of the two methods. And we're going to work with an example here in a second to demonstrate that. We're going to go back to our screen and let's go over here and see if we can do that. Now, let's consider a write of a call option. Remember, margins require rewriting an option. So the first scenario we're going to use is we're working with the call option, and we are writing. So we're selling. Let's just say we're selling 5 calls contract. We know that the underlying stock price is currently at $57 and the strike price is currently at $60. So we write 5 call contract. The current price of the stock is $57. The strike price on our call contract is $60, and the contract size is going to be for 100 shares. So 5 calls, 100 shares per call, which means that the contract, the overall sale, is for 5 times 100, which is 500 shares. That's what we're after. Now, the first method of computing the margin on our call contract says what? The first method says what we want to do, we're going to take 100%. We're going to take 100% of the proceeds from the sale of the option, and next what we're going to do is we're also going to be adding 20% of the underlying share price, and then we're going to subtract any amount by which the option is out of the money. So let's go back to our screen. Let's assume that the call price is at $3.50 per call. And so the first option says do the following: 100% of the sales of the option, right? To that we add, what did I say? To that we add 20% of the underlying share price. So we go back to our board, 20% of share price and we subtract. What are we subtracting? We're subtracting any amount by which the option is out of the money. So let's go back here. We say it's out of the money. That's our first method. So let's compute this with respect to our first method. Well, what would be our sales price for the option? Well, it's 100% of the sales price. The call price is at $3.50. So we're going to say $3.50 is what we start with. And what happens next? Well, $3.50 per call. And a call is indeed for a unit of shares. But then we have 500 shares because we have 5 contracts. So we're going to multiply this by the 100 shares and we're going to multiply this by the number of contracts. This is going to give us the amount of money by which we are, the total size of our sales of the option. That is the proceeds from our sale of the option. The second component of this is 100% of the share price, 20% of the share price. So we're going to say plus here 20%. What is that share price? $57. Multiplied by $57. But then again, how many shares do we have? Well, we have 500 shares, right? The contract is for 500 shares. We have 5 contracts, 100 shares per contract. So we're going to multiply this by 500. That's going to be our second component. Now, our last component is any amount by which the option contract is out of the money. Now, a call option is out of the money if the stock price is less than the strike price. If the current market value of the underlying is lower than the strike price, then the option is out of the money. If the current market value is greater than the strike price, the option is considered to be in the money. And so in this case, what we see is that the stock price, which is equal to 57, is less than the 60, which is our strike price. And so what we can tell here is that the stock price is less than the strike price, and is less than the strike price by the difference between the two is $3. So we know that the option is out of the money by about $3. And so the amount by which the option contracts altogether are out of the money is going to be minus $3. That's the amount by which the contract's out of money here, multiplied by the number of contracts, the number of shares that we have, right? 5 contracts, 100 shares per contract. That's going to be 500. And that is how we will be computing our the first option. So let's do that. Let's pull our financial calculator and do just that. Alright, so the first option says 100% of sales of the option, so that's going to be $3.50 multiplied by 500. That gives me $1,750. So here I have $1,750 plus 20% of the share price. So that's going to be $57 times 500 shares equal, and then we take 20% of that, multiply by 0.2 equal $5,700. So we're going to say $5,700. That's our second component. And we're going to subtract the amount by which the option is out of the money. Now 3 then multiplied by 500, that's 1,500. Now if we did the math here, 1,750 plus 5,700 minus 1,500, that's going to give us about 5,950. That's going to be the amount of money based on the first approach to computing the margin. That's going to be the margin requirement based on the first approach. What does the second approach tell us to do? The second approach, let's go back to our slide, says because we're working with a call, what we're going to do is we're going to take 100% of the proceeds from the sales, which is the same as what we had earlier. But then this time what we're going to do is we're going to add 10% of the underlying share price. So let's go back to our board. Say 100% of proceeds of sales, so 100% of the sales of the option plus 10% of share price. That's the call. And so 100% of proceeds of the sales, very similar to what we had in the first scenario. That's going to be $3.5 per call multiplied by 100 shares multiplied by 5 contracts, to which we add 10% of the share price. So it's going to be 10% multiplied by 57 multiplied by the number of option contracts that we have, which is 500. Number of contracts that we have underlying here. So in this case, it's very similar to what we had earlier. We're going to be at 1,750, and then here, because it's 10% and early on we had 20%, so it's going to be half of what we have at 5,700, which is about 2,850. Let me make sure I get that correct. So that's going to be 57 multiplied by 500 multiplied by 0.1, 2,850. So it's going to be $2,850, and that's going to be it. And so if we do the sum of this too, our margin is essentially going to be plus. I'm going to add this to 1,750. It's going to be $4,600. And this is going to be our margin based on option number 2. And overall, what our rule says is that we have to be taking the greater amount of the two, the highest of the two. So what's the highest of the two here? The first method says 5,950. Second method says 4,600. The margin requirement for this transaction is going to be at 5,950. Now let's look at an example with the put option. And with the put option, remember the first method is the same. The second method is different, and the reason the second method is different is that with the put, we're doing 10% of the strike price. And that's the only difference between the two. Okay, so let's take a look at an example with respect to the put option. There we go. So let's do this with the put. Let's assume that in this case we have 10 contracts. And the contract size is for 100 shares. The put price is equal to $8, and the stock price is at 20, and the strike price is at 25. So $25 the strike price on this put option contract, on this put option. Current value of the underlying at 20, 10 contracts, size per contract of 100 shares, and price of the put option is at $8 per share. And so the first scenario, you remember the first scenario, said 100% of the sales of the option, to which we add 20% of the value of the underlying, so stock price, and then we subtract the out of the money amount. Okay, so 100% of sales of the option. What is that? What does that come down to? Well, this is a scenario where we have 10 contracts. Each contract is for 100 shares, and the price per share is at $8 per share, so it's multiplied by 8. Okay, to this we add 20% of the stock price. The stock price is at $20, and then the contract is for 10 shares, so that's going to be for 10 contracts. So we have 10 contracts, and then each contract is for 100 shares. Okay, and then we see whether the option is out of the money. Well, now we're working with a put option contract. So for a put option, the option is valuable if the stock price is less than the strike price. So if the stock price is less than the strike price, the option is in the money. If the stock price is greater than the strike price, the option is out of the money. So the put option, what we want to see is whether the stock price is less than the strike price. So the stock price in this case is equal to 20, which is less than 25, which is the strike price. So in this case, the option contract is in the money. And because it is in the money, the out of the money amount is going to be equal to 0. So what do we have? 8 times 10 times 100, that's 8,000. 20 times 10 times 100, so that's 20,000. Multiplied by 20%, so that's divided by 4 by 5, so that's going to be 4,000. And we say equal to 12,000. That is the calculation using method number 1, right? That's going to be the first method. Our second method says use 100% of the sales of the option. But then, because we're working with a put option this time, we're going to do 10% of the sales of the strike price. The first option was 100% of sale of option, 20% strike price minus whatever 20% stock price minus whatever we have out of the money. The second option is 20% of sales of the option, 10% of the strike price. So the first component here, 100% of sale of the option, is the same. So it's going to be $10, 10 contracts, multiplied by 100 shares per contract, multiplied by 8. So that gives us 1,000, just like what we had earlier. And then the second component is 10% of the strike price. So that's going to be 10%. Our strike price in this case is 25. So multiply that by 25. And we multiply that by the number of contracts that we have. So that's going to be 10 contracts, and each contract is for 100 shares. And so in this case, what we're going to have is 25 multiplied by 10 multiplied by 100. So that's going to be 25,000. And 25,000, 10% divided by 10, so that gives us about 2,500. So this is going to be 2,500. When we add this up, we have our second calculation, which is going to give us about $10,500. And so our margin requirement is the maximum of the two amounts, right? And so our margin requirement is going to be this value here. This is going to be the margin. And we remember that when we say margin in this context, we're talking about naked option, right? So you write an option without holding this on the line, this stock for which the value is currently at $20. So if you write a contract without holding the on the line, then you're required to post margins. And the amount, the computation for the size of the margin, it is the maximum of these two methods of computation. The first method for the call, that's what we had here, was 100% of the sale of the option. That's that 100% of sale of the option, 20% of share price minus any amount by which the option is out of the money. Now that was a call option, so the out of money was the difference between the strike price and the stock price. In this, the second method of computation was 100% of the sales of the option plus 10% of the share price. This is the difference for the second method of calculation. For the call, we use the share price here. For the put, we use the strike price here. That's the only difference. The first method is the same. And ultimately what we do is we take the maximum of the two methods. Alright, so let's go back to our slides here and we continue our discussion. Now there are other type of option contracts that exist out there. We talked about flex options and dooms and so on and so forth. There are also warrants, and warrants are options that are not traded on an exchange, right? So these do not trade on exchange. And what do they represent? Well, warrants are options that are issued by a financial corporation or a financial institution, and they're issued under these financial institution owned stock. So Bank ABC issues rights options on its own shares, and so the number of warrants that are outstanding are essentially computed or obtained by the size of the original issues, and changes only occur, that is, changes to that amount of option that is outstanding only occur when they exercise or when they expire. So if an organization issues, and they are redeemed directly with the organization, by the way. So if an organization issues options, the size, the amount, the number of outstanding option contract do not change until the holder of the option contract decides to exercise the option or just let the option expire. That is what this second line here says. It says the number of warrants outstanding, those are the number of contracts that are issued by the financial institution, is determined by the size of the original issue. That is the number of option contracts that were initially issued, and that number only changes if one of two things occurs: if the option is exercised by the holder of the option, or if the option is said to die or to expire by the same holder of the option. The issuer, that is the financial institution, settles up with the holder when the warrant is exercised. So ABC Inc. issued warrants. Those are options. The holder, if they decide to exercise the option, that doesn't go through the exchange and the holder is matched with somebody else. Typically, that's what happened at the exchange. In this case, the holder addresses directly the organization, and the organization processes the exercise for the holder of the option. So when call warrants are issued by a corporation on its own stocks, exercise will usually lead to a new treasury stocks being issued. So if the contract that is initially issued is a call option, or a call warrant because it is issued by the organization itself, if that contract is a call warrant and that contract is exercised by the holder of the call warrant, the way the holder of the option contract receives the number of shares outstanding, the number of shares that are specified in the contract, is by receiving essentially treasury stock that are issued by the organization. Again, what does that mean for us? ABC Inc., which we call this ABC, issue warrants. Those are our warrants. And the warrants are on its own shares of stocks. And this is a call warrant. And we have a holder here who has the warrant. Now, if this holder decides to exercise the warrant, the holder is going to reach out to the organization. And in there, the organization is going to say, well, it is a call contract, which means that the holder is going to be buying the shares of this stock, the shares of this company at a specified price, because that's a call. And so where do those shares come from? Treasury stocks. So this firm is going to issue new treasury stocks. There's going to be treasury stocks here. And those are treasury stocks that are then going to be used to satisfy the requirement of this call option contract or this call warrant. Now, the different is different because it doesn't go through the exchange, but the process is essentially the same. The holder of the call has a right to buy. The holder of the put has a right to sell. There are also other type of options that are typical for remuneration purpose, and those are employee stock options, and they are forms of remuneration by a company to its executive and sometimes to employees. So these employee stock options are usually issued when they're when they're at the money, not out of the money. They're usually issued when they're at the money, and that simply makes sense, right? The reason they use as a part of compensation or remuneration is to provide an incentive, is to align management or executives' incentive with shareholders' incentive. And that falls in line with the agency theory, right? So that agency theory says that management and owners' objectives or incentives are not always aligned, and the way you align them is by paying or compensating executive with shares of the organization. And those options serve that purpose, right? They give the right to the executive to purchase the underlying, which is the share of the stock of the company, at the specified price. So when the option is issued at the money, and that the actions of the executive make it such that the value of the underlying increases over a period of time, those are call options, the value of the underlying increases over a period of time, then what happens is the executive can now exercise the option at the strike price, which is less than the current value of the underlying, and therefore turn around and make a profit there. That is how the incentive is offered. So when options are exercised, when those employee stock options are exercised, the company issues more stocks and sells those stocks that are issued to the option holders for the strike price. Now, because these are considered salary or remuneration, they have to be accounted for in the financial statement. And so now they are actually expense on the income statement because they are considered to be salary or remuneration or selling administrative expenses, essentially. Convertible bonds are also forms of options, or they have built-in options in them. So convertible bonds are regular bonds that can be exchanged for equity at a certain time in the future according to a pre-specified exchange ratio. Just similar to a split, what a convertible bond says is, well, the holder of this bond contract has this much time to choose whether they want to convert the bond to equity or not. And if they choose to exercise that conversion, if they choose to convert the bonds to equity, that conversion has to be made at a specified ratio. That ratio would specify how many shares of the underlying it is that the bondholder would receive in exchange for the bond that is being exchanged, that's being converted. And so those bonds are usually called convertible bonds, and they are often also callable bonds, right? They're callable because the issuer would want to have the option to retire the bond early or to force indeed the bondholder to convert. So as a bond issuer, if I give you the right to convert your bond at a specified exchange ratio, I would also want to have the right to retire the bond should you not want to convert it over a period of time. And so typically what would happen is, if it is satisfactory for the bondholder to convert the bond, the call feature would provide them an added incentive for the bondholder to go ahead and convert the bond. So the call provision, again, is a way in which the issuer or the bond issuer can force a conversion. And the reason they want to force a conversion is because without that call feature, the bondholder could essentially sit on that bond and continue receiving interest payments on the bond at a time earlier than that the bondholder might otherwise choose. So the bond issuer may want to force a conversion before it is ultimately optimal for the bondholder to do so. Now this wraps up our discussion of this unit. There's one more thing that I wanted to touch on that we didn't quite touch on here, and it's the idea of a position limit. So the exchange also imposes or specifies position limits. And what position limits, actually maybe I should write that down here. Position limit. And what position limits are essentially, what they do is that they define a maximum number of option contracts that an investor can hold on one side of the market. So a long call position and a short put position would satisfy, would be considered at one side of the market because they would both be essentially bullish. They will look at bullish signal in the market, right? So what we have is two sides of the market. We have long call and short put. And so on the other side of the market, what we're going to have is short call and long put. Now, this side of the market, long call, short put, would be looked at as a bullish side of the market, and that side of the market would be a bearish side of the market. And why do we look at this side as being bullish? Well, you buy a call option here because you anticipate that the price is going to go up, right? So you buy a call option because you feel like the company is doing good, and so you're bullish with the stock. You sell a put because you don't expect that the put option is going to be exercised. And so if the put option is not going to be exercised, it means that the price of the option, the price of the underlying, is always going to be greater than the strike price of your short put into position. So that those two make up one side of the market because they present a bullish signal in the financial market. The short call, or you sell a call option contract when you believe that the stock price is going to be falling, right? And so that is the short call is the opposite. If you sell a call option, do you actually expect that the underlying is not going to be exercised, and so you expect prices to be tumbling. And the long put will serve the opposite. The long put, you also expect the prices to be falling. You want to protect the position by purchasing a put option and having the right to sell the underlying if you wish to. So the exchange does impose a position limit. That is the number of contracts that you can hold as an investor on each side of the market. So if you on the bullish side, those are long call and short put, there's a limit, and on the bearish side, that is short call and short call long put, and that is there's going to be another position limit there. There are also exercise limit. Exercise limit essentially defines the number of the maximum number of contracts that can be exercised by any individual in any period. And that period is typically a week, a trading week. A trading week is 5 days. So this exercise limit, that is the maximum. Actually, let's do that. Exercise limit is going to be the maximum number of contracts that can be exercised within 5 consecutive days. And 5 consecutive days as 1 trading week. Alright, so this wraps up for us the discussion in this unit, where we talked about essentially the mechanics of option markets. And I will see you in the next video, and in that video what we're going to do is we're going to start our next unit. I'll see you in the next video.